In this section, we're going to talk about proportion and problem solving with rational equations. So, we need to solve proportions, and a proportion is when you have two ratios that are set equal to each other. So a ratio is just a fraction, A over B, and a proportion is when you have two ratios set equal to each other. So maybe you have A over B is equal to C over D. We can solve those by cross multiplying. So I can take a denominator and multiply it by the numerator of the opposite fraction. And I'll take this B and multiply it by C, and that gives me A times D equals B times C, which is nice because then we don't have fractions and it's easier to solve. So let's take a look at example 1. In A, I have x over 35 is equal to 9 over 7. So I'm going to take the 7, multiply it by x, and the 35, and multiply it by 9. So that means that I have 7x equals 9 times 35. And I could multiply 9 and 35, but let's take a look. Do we actually need to know what 9 times 35 is? So if 7x is equal to 9 times 35, I can solve for x by dividing both sides by 7. And the 7's cancel out on the left-hand side, and that leaves me with just x. And on the right-hand side, now I have 9 times 35 divided by 7. And this is a lot easier. I can go ahead and 7 into 35 goes 5 times. 9 times 5 is 45. So that's my final answer. Now I do want to stop and take a look at the initial ratios that we had there. So what were the ratios that we had to start with? Did they have a variable in the denominator? They did not. So this is fine as an answer. If I have a variable in the denominator, I have to check to make sure my answer doesn't make the denominator 0. But we're all set here. X is 45. We can move on with our lives. So now let's take a look at part B. A little more complicated. X minus 3 over 4 is equal to 7x plus 35 over 60. Again, I'm going to cross multiply. And I have 60 times x minus 3 equals 4 times 7x plus 35. So I can go ahead and distribute the 60. And I could have done that when I was doing the cross multiplication. So that's just your own personal preference if you want to take an extra step or not. Whichever is fine. And then I distribute the 4, and 4 times 7x is 28x. 4 times 35 is 140. And now I can just go ahead and solve this like a regular linear equation. So 28x, we're going to subtract from both sides. So I'll add the 180 to both sides to get the constant terms together on the right-hand side. So here I get 32x is equal to, on this side, I have 320. So now I just divide both sides by 32. And x equals 10. And again, no variable in the denominator, so cha-ching, that is my final answer. All right, so here we just solved a couple of proportions, but what you're going to see more commonly is that you have a word problem and you're going to have to set up the proportion. So when we're working with proportions, we're going to have 4 quantities. So just like we were talking about a minute ago with proportions, you have A, B, C, and D. So the question is, how do you identify what goes in each place? How do you know what quantity is A, what quantity is B, and so on? So what you're looking for is some common relationship within the fraction. So this is relationship number 1. This is going to be the same relationship. So maybe we're talking about triangles that are similar to each other, and A and B come from the same triangle, and C and D also come from the same triangle as each other. So that's my first relationship, is that they both come from the same triangle. Then I look at side A. What side does that correspond to in the second triangle? It corresponds to side C, right? So those are the matching sides. So that's the relationship that I have here. So that's going to be relationship 2. And these also have that same relationship, that B corresponds to D. Okay, so that's what we're looking for in these proportions. Let's take a look at a problem. So here we want to find the unknown length in the pair of similar triangles. So the unknown length is x. So we're going to start with that. That's going to be A for me, because we definitely have to have that in the problem. Now, I'm going to choose, the relationship is that I'm going to choose one of the sides from this same triangle. My choices are 4 and 20 over 3. And I'm going to go with 4, because why would I choose a fraction if I didn't have to? So that's my first fraction. And now I need to make another fraction with 2 sides from the same triangle as each other. So how do I know what goes on top and what goes on the bottom? So I look at this side, x, and I match it up with this side, because the triangles are drawn similar to each other. We can see that they have the same orientation. You can see the proportions of the sides. Those definitely correspond to each other. So x and 18 are matching sides, right? And then the 4 is going to match up to the 12. Okay, so now I have my proportion. X is to 4 as 18 is to 12. So now I'm going to do my cross multiplication, and I get 12x equals 72. And then I'll just divide both sides by 12. And x equals 6. Final answer. And in a geometry problem, it's always going to have a solution that works. So we're all set there. Now let's take a look at example 3. In this problem, they tell us that 12 divided by the sum of x and 2 is equal to the quotient of 4 and the difference of x and 2. So I start off with 12. And then it says divided by the sum of x and 2. So the sum of x and 2 means x plus 2. And that's going to equal the quotient. So quotient means that we're dividing, of 4. So 4 goes in the numerator. And the difference of x and 2. Difference means that we're subtracting, so it's x minus 2. So there's my proportion. And now I can cross multiply, and I get 12 times x minus 2 is equal to 4 times x plus 2. And I can distribute. And let's bring that up to the top here. And now I'm ready to get my like terms together. So I subtract 4x from both sides, add 24 to both sides. And on the left-hand side, I'm going to get 8x. And on the right-hand side, I get 32. So I can divide both sides by 8. And x equals 4. And it's just asking me for the value of x. It doesn't have any units. So 4 is my final answer there. Now again, I do want to make sure that it doesn't give me 0 in the denominator. So 4 plus 2 is 6, 4 minus 2 is 2, so no problems with not having a solution. Okay, now let's take a look at work problems. In these problems, you are given the amount of time it takes for 2 or more individuals, whether they're people or machines, to each complete a task. So you're going to be told that one person can complete this job in 10 hours and another person can complete the job in 7 hours. So the first person can complete 1/10 of the job every hour. We're assuming that they're working at a steady rate. And the second person would be able to complete 1/7 of the job in every hour. And so what we're going to do is we're going to find the amount of time that it would take them to complete the job working together. So we're going to find what part of the job they complete working together in 1 unit of time. So if the time is in hours, we're talking about what part of the job they can do together in 1 hour. If it's in minutes, then you do it in what part of the job they can do in 1 minute. So we're going to add the 2 portions of the job that they can each do separately together. That's going to give us the part of the job completed working together. And we multiply that by x, which is the time to do the job together. And that's what we're trying to solve for in these problems. And so if you multiply those together, you get 1 job that's completed. So let's take a look at a problem and see how this works out. It's not as complicated as it sounds. Okay, so in this example, we have an experienced bricklayer and we have an apprentice. The experienced bricklayer can construct a small wall in 3 hours. And the apprentice does the job in 6 hours. Okay. So what I want to find then is what portion of the job can be done by the experienced guy in 1 hour. So I just have to take the reciprocal of the amount of time it takes him to do the job. If he takes 3 hours to do a job, he's getting 1/3 of the job done every hour. The apprentice takes 6 hours to do the job, so he's going to get 1/6 of the job done every hour. And now we want to look at what can they do together. So if they're working together, how much of the job is going to be completed at the end of the first hour? Well, the experienced guy does 1/3 of the job. The apprentice does 1/6 of the job. So we have 2/6 plus 1/6, and that gives me 3/6, which is 1/2. Okay, so they're getting half of the job done every hour. So if they get half of the job done every hour, 1/2 times the amount of time it would take them is going to equal 1 job. So all I have to do is multiply both sides by 2, and x is equal to 2. And that was in hours, so we say x equals 2 hours. That's my final answer. Let's try a similar problem. In this one, it says Mr. Dodson can paint his house by himself in 4 days. All right. Mr. Dodson. So he takes 4 days to complete the job, and that means that he's going to get 1/4 of the job done every day. Then there's his son. And the son needs an additional day to complete the job if he works by himself, so that means he needs 5 days to do the job. And that means that working steadily, he would get 1/5 of the job done every day. So what happens if they're working together? So we're assuming a couple of things here. We're assuming that they're working at a very steady rate and they're always getting the same amount done every hour. And we're assuming that working together doesn't speed them up or slow them down. So they're just working at their own particular steady rate. And we've got 1/4 plus 1/5. So how much of the job is getting done in that first day? Let's get common denominators. And I get 9/20 for that. So they're getting 9/20ths of a job done each day. And we multiply that by the number of days to complete the job. And we get 1 job completed. So to solve for x, I just multiply by the reciprocal of 9/20. So I'm multiplying both sides by 20/9. On the left side, I'm just left with x. And on the right side, 20/9, or 2 2/9. And that time is in days. So cha-ching, there's my answer for that. Now let's take a look at a problem involving our formula for rate, time, and distance. So we know that rate times time is equal to distance, and I'm going to use that formula to set up the problem. So we're told that 2 cars are leaving Sarasota at the same time, traveling in opposite directions. So I'm going to start with Sarasota as my location, and I have 1 car that's traveling north and one car that's traveling south. Now, one car is going faster than the other. So what I want to know is what is the rate for each car? Okay. So we have car number 1 and car number 2. I'm going to make a little table. And I have the rate, and I know that rate times time is equal to distance. So I basically make my table out of that formula. All right, so one car is going 8 miles per hour faster than the other car. So one of the cars is going X miles per hour. The other one is going 8 miles per hour faster. So that's going to be X plus 8. It doesn't matter which car is which. And what do we know about the time? We know that they're going for 2.5 hours. So I'm going to put that time in. Now, at the end of the 2.5 hours, the two cars are going to be 250 miles apart. But I don't know how far they went individually, right? I don't know that one went 150 miles and one went 100 miles. So what I'm going to do for distance in this table is I'm just going to take the rate times the time for each of the cars. So for car number 1, distance is 2.5 times x. And for the second car, the distance is 2.5 times x plus 8. And what do we know about the distances? Well, we know that they add up to 250 miles. So I'm going to distribute. And let's see, 8 times 2.5 is 20. And there we go. So 2.5x plus 2.5x gives me 5x. I'm going to subtract 20 from both sides. So that 5x is equal to 230. I'll go ahead and divide both sides by 5. And that tells me that x is equal to 46. Now in this question, they want us to find the speed of each car. So the car that was going X miles per hour was going 46 miles per hour. And the car that was going X plus 8 miles per hour is going 46 plus 8, or 54 miles per hour. So that is my final answer. All right, one more question here. So this says the current on a portion of the Mississippi River is 3 miles per hour. A barge can go 6 miles upstream in the same time it takes to go 10 miles downstream. We want to find the speed of the boat in still water. So again, we're using our formula, rate times time equals distance. But in this scenario, we know something about the rate for each direction, right? When it's going upstream, then it's going against the current. When it's going downstream, it's going with the current. So I know about the rate for each. I know something about the rate. I don't know what the rate is, but I know something about the rate for each of those. And then I know the distance that they're going. Upstream, they're going 6 miles an hour. Downstream, they're going 10 miles or sorry, not 10 miles per hour, but it's going 6 miles upstream, 10 miles downstream. What I don't know about is the time. I know that the times are equal to each other, but I don't know what the time is. So what I'm going to do is I'm going to solve this formula for time, and I'm going to say time is distance divided by rate. Okay. So we have a boat going upstream, and it also goes downstream. And when it's going upstream, it goes 6 miles. When it goes downstream, it's going 10 miles. The rate, when it's going upstream, it's going its speed in still water minus the 3 miles per hour of the current. Because when it's going upstream, it's fighting the current, it's getting slowed down. When it's going downstream, it's going faster because of the current. So since we know that time is distance divided by rate, I'm going to make the time for going upstream 6 over x minus 3, and the time for going downstream is 10 over x plus 3. And then I can set up my equation by just setting those two ratios equal to each other. So I have 6 over x minus 3 equals 10 over x plus 3. Cross multiply. And distribute. And now I'll get my like terms together. And I get 48 equals 4x. Divide by 4. And I get x equals 12. And that is in miles per hour. That's my final answer.